This is a video intended to help you understand the basics of binary search tree. A tree is a data structure which is a collection of 0 or more nodes and a finite set of directed lines that connect the nodes. The first node in the tree is called root node. Remaining nodes are partitioned into subtrees. A node whose degree is 0 is called a leaf node or a terminal node. The other nodes are therefore referred to as non-terminals or internal nodes. All nodes reachable from another node by a single edge are called children of that node. Two or more nodes having the same parent are called siblings. The level of a node is defined by setting the level of root node as level 1. The height of a tree is the maximum level of any node in the tree. A binary tree is a special type of tree which has a condition that each node can have at most two children, called left child and right child. The first level has only one node, the root. Each of the next levels can have at most twice the number of nodes in the previous, which is when every node has two children. Summing them up, we get a geometric progression that says that there can be at most 2 to the power of L-1 nodes in a tree with L levels. There are 3 types of traversals based on the order in which the nodes of the tree are visited. In in-order traversal, we visit all the nodes in the left subtree followed by the root and finally all the nodes in the right subtree. In pre-order traversal, we visit the root first and then the nodes in the left and the right subtrees. In post-order traversal, we visit the nodes in the left and the right subtrees and then the root. In in-order traversal, it starts from the root, which is 25, and goes to the left child with value 10 and then to its left child which has value 50. 50 has no left child and is printed. It has no right child and the execution returns to 10 which is printed and then continued to its right subtree that prints 35 and 20 and then back to the root and to its right, printing 25 and 30. Similarly, we get the pre-order and post-order traversals as shown. We consider a particular kind of a binary tree called a binary search tree. A binary search tree is a binary tree which satisfies the following conditions. Each node contains a unique value, usually called a key. At each node, the keys in the left subtree are lesser than that in the node and those in the right subtree are greater. The tree shown in the figure is not a binary search tree because it violates the condition of binary search tree. Node 27 which is in the left subtree of 25 is not lesser than 25. Searching for a value in BST is similar to searching for a value using binary search. Let k be the value to be searched for. We start from the root. If k matches with the value in the current node, we return success. If k is lesser than the value in the current node, go to the left subtree, otherwise, go to the right subtree, and repeat from step 2. If there is no node to go to, we return failure. Let's consider 2 examples. Firstly, when we have to find 15, we start from the root, which is 25, and then go left as 15 is smaller than 25. We go right as 15 is greater than 10 and stop since we found the required key. Usually, a node in a binary search tree can have only a key, which helps in checking the existence or have a value along with it which can be used for any other task. Now, let's see what happens when we try to find 35. We start from the root again, which has 25 and then go right to 30 and now we need to go right as 35 is greater than 30. But 30 has no right child and hence we declare failure. Let's take a look at a few observations on the search algorithm. All the nodes from root to the node being searched for, are visited exactly once. In the worst case, we'll have to traverse till a leaf that is the farthest from the root, thereby visiting the number of nodes equal to the height of the tree. So, the worst case time complexity is big O of height. If you have any questions, post it in the comments below or post them on code.msrit.net. The link is in the description below. The various operations on binary search trees will be described in the next video. The link to the video will also be put up on the same website. Do watch. Thank you. Happy coding!